Okay, longest consecutive sequence. Given an unsorted array of integer nums, return the length of consecutive elements sequence. You must write an algorithm that runs in order of n time. And here's an example where input is 100, 4, 200, 1, 3, and 2, and output is 4. Why? Because the maximum or the longest consecutive sequence here is 1, 2, 3, and 4. Let's try to understand this with a simple example. First of all, sequence means anything which is present in an order. Consecutive means we want it to be one after another, let's say 2, 3, and 4, like this. And longest means out of all the sequence present, we need to find the sequence with the longest length. So let's say we have n equals to 2, 20, 3, 5, 4, 21. So here we have two consecutive sequences. First one is n1, 2, 3, 4, and 5, and n2 is 20, 21. As we can see from the question, the array could be unsorted. So from here, length 4, it is of length 2. So maximum or longest consecutive sequence over here is of length 4. That is the answer. Let's try to find it out using brute force approach. What is brute force approach here? What we can do? I will rewrite it so that we can start it fresh. 5, 4, and 21. Over here, what we could do is we can start with this element of an array and try to find whether we have an element plus 1 for, so I'm talking about, we can find whether 2 plus 1 is present. Yeah, it is present. Then I'll try to find out whether 2 plus 1 plus 1, like that is 3 plus 1 is present. Yes, it is present. Plus 1. Then 3 plus 1 is present. Sorry, 4 plus 1 is present. Yes, it is present. 5. Is 5 plus 1 present? No. So till here we have the longest consecutive sequence that is of length 4, or maybe consecutive sequence of length 4. Then we'll try with second element, that is 20. So for 20, do we have 20 plus 1? Yeah, we have it. So length of this is, and then do we have 20 plus 1, 21 plus 1, 22? No. So longest, or maybe the length of the sequence for 20 and 21 is 2. For 3, we'll try for 3 as well. Do we have 3 plus 1? Yeah, we have 4. Do we have 4 plus 1? Yeah, we have 5. Do we have plus 1, 5 plus 1, 6? No, we don't have. That means here the length, consecutive sequence length is 3. So we'll try to do it this way. Let's code it and check how we can solve it actually. So let's try. So we'll try with this. For num in nums, what we have to find out? We'll check for each element whether that element plus 1 is present or not. So we'll first store it in a variable num, and we'll have a local counter, let's say length in gth. So that would be 1. Now I have to find whether the current element plus 1 is present, and we have to find it out till the current plus 1 element is not present in num. So that would translate to while current plus 1 in nums. If this is so, then we'll increment the current one, that is here. If it is 2, then we'll make it 2 plus 1. If it is 3, then we'll make it 3 plus 1. So, and then we'll also increase the local counter, length plus equals to 1. Now out of all this length, so for here we had a length of length 4 for 2, for 20 we had length of 2, and for third element, that is 3, we have a length of 3. So we'll do it for 5, 4, 21, and then we'll figure out the maximum of all. So for that, we'll have one more global variable to hold the max of all. So longest will become max of longest, comma, length. Then we'll return int longest comma longest. Great. So as we can see, we have our answer, that is longest equals to 4. And that makes sense. But as we can see, we are using two loops and this solution is translated to order of n square, which is not optimal. So what is the next approach which we can try to make it better? As we can see, I'll rewrite the sequence, that is 2, 20, 3, 5, 4, 21. What if we try to sort it? So let's say I sort it and I have 2, 3, 4, 5, 20 and 21. Now I have made my life easier because after sorting I have got a genuinely consecutive sequence, and my only role now is to, for each element, I'll try to find out whether there exists an element greater than that and how many elements greater than that are present. So for 2, let's say I have 2 plus 3, 2 plus 1 3. Then does 3 exist? Yes. Then 3 plus 1 4. Does 4 exist in nums? Yes. 4 plus 1 5. Does 4 exist? 5 exist in nums? Yes. Then similarly I'll try with 3. I'll check whether 3 plus 1 4 exists. Yes. 4 plus 1 5 exists. So for 2, my length of the consecutive sequence was 4. For 3, I have 3 plus 1 4, 4 plus 1 5. So here the length is 3. For 4, shall I write it here? For 4, I have only 4 plus 1 5. So that is 2. For 20, for 5, sorry, for 5, I don't have anything greater than 5. So it is of length 1. Similarly, for 20, I have 20 plus 1, 21. Yes. So length would be 2. And then last comes 21. Do I have 21 plus 1? No. Then I shall try this as length 1. And what is maximum of all? That is 4. Then we will write 4. So if you see, we only need to do sorting, and that is order of n log n. And rest of the checking would be order of n. But collectively we will have our solution order of log of n, and that is kind of a better solution, better than the brute force. So let's try to code it now. Let's do it here. I'll check uh, using sorting. So we'll first sort nums uh, nums dot sort will it in place, and now if you see our um, sequence has become 2 comma 3 comma 4 comma 5 comma 20 comma 21. And then what we'll do is I'll iterate through for I in range 1 length of nums, and I'll try to find out whether if nums of I equals to nums of I minus plus 1. If this is so, then as we have discussed here, we'll increase the counter. So here, let's have a counter of length bn plus equals to 1. But what if we don't have an element greater than 1? In that case, let's keep the length as it is, equals to 1. And then we'll override this with the longest. So longest would be max of longest comma length. And then we'll print once again longest sequence length using sorting is longest, and that is 4. But if we see, there could be repetition, right? For there could be 1 and 1, and we don't need to account for this because anyways that won't make sense. If there is 1 and 1, we still need to check, or we don't need to worry about it. So to handle that situation, what we could add over here is, if nums of I equals to nums of I minus 1, then I could simply continue. I don't need to worry about it. Great. Okay. Uh, I have made some mistake over here, it seems. Oh, okay. Length should be, I should make it a variable length, initialize it because over here it was already incremented. So now, yes, now its longest sequence length using sorting is 4. Now let's try to check whether we can optimize it more. So as in the question we have seen that we can try to solve it in order of n time. So in order to do that, sorting has already cost us n log n. So what could help us to solve it in order of n? I guess it should be set. Why? Because we'll check it only, we'll iterate it using only going through whole sequence, that is 2 comma 20 comma 3 comma 5 comma 4 comma 21. Let's try to do that. This is our set. Let's try to fill it. Let's say we have 2, 20, 3, 5, 4, and 21. Till now what we were doing, for each and every each and every element, we were trying to find the sequence. But this is a repetitive task. If I have my, if I am at 3 and I know 2 has already come previously, then it's not of any use to literally move forward, because anyways 2, 3, 5, 4, 5 has covered that length, and length of 2, 3 would be always be greater than length of 3, 4, 5. So idea is, whenever we check in set for each element, we'll check whether minus 1, that element minus 1 exists or not. That would help us determine whether that is the start of the sequence. Remember, let's say we are at 2 and we find, is 2 minus 1 in the set? No. So this is our start of sequence, and then we'll start to find the same thing which we have done earlier. But let's say we have come at 20. We'll check whether 20 minus 1, 19 is present. No. Then if that is not present, then this is our start of sequence. Then I'll check for 3. Is 3 minus 1 present in num set? Yes, it is present. So this cannot be start of the sequence. So we won't move forward with that. Let's try to code this and then you will understand if this makes sense or not. We'll remove this. Okay, so we are starting with our third approach, that is the optimal solution using HashSet. So first of all, we'll create a set that is num set equals to set of nums, and then we'll start our code. That is, we'll check as we said, for num in num set, we'll find out if that is the start of sequence. And how do we find that out? We'll check if num minus 1 not in num set. If this condition is true, that means n minus 1, that is 2 minus 1, 1 is not present. That means that is the start of sequence. And then we'll check whether length equals to 1, and I'll do y length plus, oh sorry, num plus length, and this length will go on increasing by 1 in num set. If it is so, then length is equals to 1, and I override it with max of longest comma length, and finally we can write print longest sequence length using HashSet comma longest, and let's run this, and as we see, longest sequence length using HashSet is 4. Great. So That's it. Now we have found out that using HashSet, we get our optimal solution. Let's paste it our lead code now and check whether this works. Return longest. Okay, let's. We haven't checked the condition where nums could be an empty string, and for that, either we can add a condition that if length of nums is 0, then the longest sequence is 0, or we can directly start our longest variable from 0, and then we'll submit once again, and now it will pass it. That's it. Thank you. Let's meet at another lead code challenge.